Welcome student, myself Dr. Mohit Saxena. I will teach you probability in this particular lecture. In this particular lecture, we would study three topics: discrete probability distribution, continuous probability distribution and binomial distribution. These are the topics which we are going to carry in this particular lecture. Now, before going to these topics, we must know what are random variables. Random variable has a defined set of values with different probabilities. Random variables are of two types: discrete random variable or continuous random variables. Discrete random variables means finite number of which having finite number of outcomes like dead alive, pass fail, dice, counts, etc. And continuous number of continuous random variable is variables which having infinite possibilities of value like selection of a student on basis of his height. Height may be any value between 4 feet to 6 feet. So, this is continuous random variable. Graphically, if we see the difference between discrete random variable and continuous random variable, in discrete random variable we just get value at particular points, and in continuous random variable like a case of height, we get a complete spectrum of values at every points. So, this is a basic difference between discrete random variable and continuous random variable. Next is discrete probability distribution. This is our first topic, discrete probability distribution. If our random variable is x and it contains values from x1 to xn and their corresponding probabilities are p1 to pn, then the distribution function fx represented by sigma of f of xi, which is equals to sigma of pi, is known as distribution function, where what is fxi? Fxi is equals to pi if x is equals to xi and it is 0 otherwise. The probability distribution of a discrete random variable is a list of each possible values x together with the probability that x takes that value in one trial of experiment. Okay. Properties of discrete distributions. They are simple same properties as we study the properties in Venn diagram, that for two random variables a and b, the union of A union B and probability of that is equals to probability A plus probability B minus probability A intersection B, A and B. If we take union of these two variables, then what is union of these two variable is same, governed by this formula. What is complement of a variable? Complement of a variable A is, if we want to find out, this is A, this is B and its complement. Complement means this particular value, and obviously intersection of A and B, probability of intersection of A and B is probability of A multiplied by probability of B. This distribution, discrete distribution, is very important distribution because various cases in our life and our neighborhood apply and usable for these types of distributions. Examples of discrete distributions are binomial distribution, Poisson distribution. You might heard about binomial distribution. Well, other type of distribution are also as such, like Poisson distribution, geometric distribution, hypergeometric, multinomial, negative binomial and so on. Different type of cases, these different type of distribution are applicable. If your sample is small and probability of happening is reasonably good, then binomial distribution is applicable. If sample size is very big and probability of happening is very low and q is almost equals to 1, then Poisson distribution is very applicable. Geometric distribution, when there is a success after r minus 1 failure, then geometric distribution is applicable. Hypergeometric distribution, when conditional probabilities are there. Multinomial distribution, if type of random variables are more than one and their probabilities are different, then multinomial distribution is applicable and so on. Let us solve a question on discrete probability distribution. What discrete probability distribution means? Value of x random variable as well as their probabilities, just represented in the form of a table. The fair coin is tossed twice, x be the number of head observed, construct the probability distribution of x. If a coin is tossed 2 times, then this might occur first time head, second time head. It might occur, second case is first time it occurs head and second time it occurs tail. Another case, it might comes that tails occur in first time and head occurs in the next time. And fourth case, when both time in both toss only tails occur. So, maximum possible outputs are 4, 1, 2, 3, 4. Now, what our question is? Question says the number of head observed. The first case is when no head observed. When no head observed is the case when we get just TT, that tails at both, and probability of TT is, this is single case and 1, 2, 3, 4. Total number of events are 4. So, this is equals to 1 by 4 or 0.25. One head occur when first time head, second time tail, or in next case first time tail and second time head. In both cases one head occurs and their respective probability is 2 upon 4. Third case, when head occurs 2 times. When head occurs 2 times, this is the only one case and its probability is 0.25, that is 1 by 4. So, what is discrete probability distribution? Write down x values of x and their probabilities. In a table you would get a discrete probability distribution. Come to second type of distribution, which is continuous probability distribution. When your random variable is continuous, then obtained distribution is continuous probability distribution. Continuous random variable and their density function Fv define the continuous probability distribution function. This is continuous distribution function. Fx is equals to minus infinity to x. Be focused, their limits are minus infinity to x. Fv dv. What is Fv? Fv is probability density function. Now, this Fx is known as continuous distribution function. If we like to find out a probability of this particular function, then probability between the limit a to b is equals to Fb minus Fa and can be obtained by this particular formula. Here you must be clear in your mind that total integration from minus infinity to infinity of probability density function is always be equals to 1. It would not be greater than 1 because complete probability is just equals to 1. Now, what are the properties of continuous distributions? There are certain properties of continuous distribution. First of all, here outputs are measured, not counted. Like probability discrete distribution, we just count the output 1, 2, 3, 4, 0.1, 0.2, 0.3. Here we just measure the value by this integration, like the case of a temperature, and usually it is defined by a curve. Now, total area of the curve is equals to 1 because complete probability is not be greater than 1. So, whatever your function is, the total area between the limit is not be greater than 1, and for any particular condition x lies between c to d, the area of this particular curve defined the probability. If we want to find out the probability of a continuous distribution over the limit c to d, then we just find out the area bounded between these 2 points. Okay. Example of continuous distribution. There are various type of continuous distribution and you will study in your subjects of probability. here we just take a slides on the classification of probability, continuous probability distribution. First and foremost, which is most important, is normal distribution, normal probability distribution governed by function 1 upon sigma under root pi e to the power minus x minus mu whole square upon 2 sigma square. This is the maximum applicable distribution in probability. Second one is student t distribution. When n is small and sigma is not given, then we apply student t distribution. Chi-square distribution. Chi-square distribution, when some certain null hypothesis is given and we just finding out distribution in terms of certain null hypothesis, then chi-square distribution is applicable. F distribution, when we compare two chi-square distribution, then F distribution is applicable. Question on continuous distribution. Let us take a question. Let x has a probability density function governed by this particular function, x lies between minus 1 to 1 and 0 otherwise. Now, what would be continuous distribution function? If f x is equals to this, then what should be continuous distribution function? For continuous distribution function, this is probability density function. We just integrate this probability density function over the limit minus infinity to x, but our function is defined between minus 1 to 1. So, minus infinity to x can be written as minus infinity to minus 1 and minus 1 to 1, and when we integrate, the first part gives you 0 and this particular limit gives you, after integrating, this value. This function is f x is equals to 0.5 plus 0.75 x minus 0.25 x cube gives you probability distribution function. Previous was the case theory of continuous distribution. Now, let us take a discrete distribution, which is very important distribution, binomial distribution. The binomial distribution is the most applicable distribution to find out the probability of tossing a coin, playing a cards, or any discrete variable type of case. A binomial distribution describes the behavior of a discrete random variable x if following condition meet. What are the conditions? N is fixed, that is maximum observation is fixed. Second one is each observation is independent. Independent means if we toss a coin, then first time it head occurs, then second time it may occur head or may occur tail. So, observations are independent and observations have two outcomes. One is success, another is failure. If three conditions hold, then binomial distribution is applicable, and formula of binomial distribution is very simple, that is equals to P r n C r p to the power r q to the power n minus r. We can say we can also verify if we take a binomial distribution, then distribution at 0, distribution at 1, at 2, at 3, at 4, at 5 and 6, the discrete value distribution. Okay. Next one is how this formula come. This NCR p to the power r q to the power minus n minus r. Event A occur and in n trials, out of these n trials, r times success case and n minus r times failure case. If success occur r times and failure occur n minus r times, then total probability is equals to p to the power r q to the power n minus r. And the rearrangement of these, there are r p's and n minus r q's. If we take whole combination of this, then total permutation of n things, two classes r p and n minus r q is factorial n upon factorial r factorial n minus r. This is also known as NCR. Multiplied this permutation with the obtained probability formula, we would get probability function. Probability function is NCR p to the power r q to the power n minus r. This is the basic formula of binomial distribution. In this binomial distribution, few points are important to understand the concept. First one is mean, variance, skewness and kurtosis. Mean of a binomial distribution is equals to NP. Variance of binomial distribution is equals to NPQ, and to find out skewness and kurtosis, as we know, we must try to find out first mu 3 and mu 4 and beta 1, then skewness is equals to, be remembered this is important formula, 1 minus 2 p upon under root NPQ, and kurtosis which is equals to beta 2, this is equals to 3 plus 1 minus 6 NP upon NPQ. For a binomial distribution, skewness is positive if p is less than half and skewness is negative if p is greater than half. Now, we try to solve certain questions on this binomial distribution. Nowadays, most of the students are studying online and appearing in their examinations online. Here you can understand, if you do not study mathematics or any topic well thoroughly, then what is the chance of your success or failure? Let us take a question on this. If you are appearing in an objective type of question set in which every question have 5 answers and out of these 5 answers, 1 answer is correct. 5 possible answers and only 1 answer is correct, and 10 questions are given to you. Then what is the probability that your 1 answer is correct? Now, for this, just take n is equals to 10, probability of correct answer. There are 5 answers as such and only 1 answer is correct. So, probability of correct answer is 1 by 5, which is equals to 0.2, and from probability formula, as we know, PR is equals to NCR P to the power R Q to the power n minus R. So, what is the chance that your 1 answer is correct is factorial 10, NCR is factorial n upon factorial R factorial n minus R, NCR is factorial n upon factorial R factorial n minus R. We put this in the formula, then 10 C1 P to the power 1 Q to the power 10 minus 1. This is equals to factorial 10 upon factorial 1 factorial 9 0.2 ki power 1 0.8 to the power 9. If we just simplify it, we would get probability is equals to 0.2684. That is, your 1 answer is correct out of 10 answer is just chance 26%, 0.2684. The second part of this question is, what would be the chance that your all 10 answers are correct? All 10 answers are correct means your R is equals to 10. If your R is equals to 10, in this case if R is equals to 10, then probability of 10 is equals to 10 C10 P to the power 10 Q to the power 10 minus 10, which is equals to factorial 10 factorial 10 factorial 0 P matlab means 0.2 to the power 10 and 0.8 to the power 0. This is equals to 0.1234561, 1. That is 0.00001% chance is there that student get all its 10 answer correct. So, be study seriously and thoroughly, otherwise you are going to be fail. Okay. Next, move to next question. In a college where 20% students are girl, in a random sample of a 5 student for a party or for a picnic or for a trip, then find the probability that there are at most 2 girls are there. So, in that particular college there are 20% students are girl. So, what is the probability of girl student is? Probability of girl student is 20 upon 100. 20 upon 100 is equals to 0.2. Probability of girls to be chosen, and at most 2 girls. There are 5 girls to be chosen and at most 2 girls. At most 2 girls means at most 2 girls. In this, there is first case when no girl is chosen, second case one girl is chosen, and third case 2 girls are chosen. So, there are 3 cases which comes and which forms a case of at most 2 girls. Now, we find out probability of these 3 cases by the formula. First one is when no girl is chosen, 5C0, 0.2 is the probability of girls to be chosen to the power 0, 0.8 to the power 5 plus 5C1, 0.2 to the power 1, 0.8 to the power 4 plus 5C2, 0.2 to the power 2, 0.8 to the power 3 respective. We use this formula in all these 3 cases and obtained their numerical value, which is equals to 0.9428. In terms of percentage, we can say almost 94.20% chance are there that at least 2 girls are chosen for a particular trip in the school in which 20% students are girl. This is the typical case of questions of probability. Next question we just see in a manufacturer company, there is a manufacturer who manufacture pistons, and he know that on an average there are 12% of his projects are rejected. There are 12% products of his production is rejected. Find probability for n is equals to 10, sample size is 10, then less than 2 are rejected and at least 2 are rejected. Basically, this is a bit confusing type of words, less than, greater than, at least. You must be crystal clear in your mind what means less than 2, what means more than 2. In a sample size of this particular factory or this particular manufacturing units, he is supplying product in batch of 10 products. Now, first of all, probability of his product to be rejected is 12%. So, probability of his product is rejected is 12%. 12% means 0.12. Now, probability chance that his product is not rejected is 0.88. Now, first we obtain the value of P and Q. Now, just take first case, less than 2 are rejected. Less than 2 are rejected means no product is rejected, one product is rejected. So, no product is rejected formula is 10C0, 0.12 to the power 0, 0.88 to the power 10, because sample size is of 10, and one product is rejected is 10C1. What is the value of P1? 10C1, 0.12 to the power 1, 0.88 to the power 9. Simplify it, we would get numerical value is 0.6582. It means almost 65% of his product, there is a chance of 65% that less than 2 product of his dispatch is rejected. Second case, at least 2 rejected. This is an important case. At least 2 rejected means 3 product might reject, 4 product might reject, 5, 6, 7, 8, 9, 10. And we know basic concept that summation of all these probabilities is equals to 1. No product rejected, 1 product, 2 product, 3 product, up to 10 product rejected is 1. And you have to find out at least 2 are rejected. At least 2 rejected means more than or equals to 2, 2, 3, 4, and by using this formula, this is equals to 1 minus P0 plus P1. Find out value of P0 and P1. We use this formula of binomial distribution NCR, P to the power R, Q to the power n minus R. P0 is equals to 10C0, 0.12 to the power 0 and 0.88 to the power 10, and P1 is equals to 5C1, 0.12 to the power 1, 0.88 to the power 1, and numerically it is equals to almost 0.3417. So, at least 2 rejected means probability is 0.3417, less than 2 rejected is probability is 0.6582. Now, come to next question. In a diced bias, of course, rolling dice is always be unbiased, but in this case there is a diced bias and throw 30 times. In a diced biased die throw 30 times and a number of 6 seen in 8, means when we throw a dice 30 times, then 6 occurs just for 8 times. If the die is further thrown 12 times, then find out expectation number of 6, variance of 6 and standard deviation. So, probability of a number occur in that particular die is this is 6 is 8 30 times. So, favorable case is 8 and total case is 30, this is equals to 4 upon 15, this is value of p. And if this is value of p, then you can easily calculate value of q is equals to 1 minus p is equals to 11 upon 15. Now, expectation. What is expectation? Expectation for a binomial distribution is equals to NP. N is 12 because dice A further throw 12 times. So, N is equals to 12 and P is equals to 4 upon 15 and expectation of 6 occur is 3.2. Variance is equals to NPQ, which is equals to 2.347 and standard deviation is under root of variance, which is equals to 1.531. So, hope you understand the concept of distribution, discrete distribution, continuous distribution and this binomial distribution. Okay, thank you beta.